So in this video we want to talk about superposition. It's super like Superman and position. We're still talking about waves, so it's superposition of waves. Okay, so what is superposition of waves? It's kind of a fancy word really. You could substitute the word adding of waves. Or if you wanted to be slightly more technical, you could talk about interference of waves. That's where their waves add together or subtract, depending on how you look at it, to produce a combination effect. So let's have an example and you'll be able to see what I mean. Here is one wave. And here is another wave. Now what you'll notice is that they are both in phase with each other, so they have the same phase. So what we would find is that if we were to add those together, when they're in the same phase, we would get another wave that would have double the amplitude. Okay, so wavelength is the same, so that wavelength is still the same. So, but the amplitude, the amplitude is from the equilibrium position to a peak. Okay, if that's A and that's A, ignore that little bit on the bottom, then the amplitude here is 2A. Twice A. So that's really important to take note of. So first the amplitude, and that the wavelength is the same. So there's no change in wavelength, no change in frequency. The only change is you've added the amplitude to each other. Okay. Another example. This time we're going to have two waves that are what? Out of phase. There's our central line for each of them, a bit roughly drawn. Let's see if we can shrink that down. There we go. And when we add these together, we get nothing. When they're exactly opposite or out of phase, then they will cancel out perfectly. Okay, out of phase is a tricky term or phrase, because out of phase could mean just that it's 10 degrees out. Whereas the example we've got above here, that is 180 degrees out of phase, so that's exactly opposite or exactly out of phase with each other. So out of phase, just be aware that you could be dealing with 10, 20, 33.7 degrees, or any sort of amount out of phase. So just looking again here, the wavelength, well, it's irrelevant in this case because the wavelength is, there is none. And the amplitude, one's positive and one's negative, so they just cancel out to give zero amplitude. Okay. Now, here's one little interesting factor for you to think about. In fact, let's just make that really little and move it out of the way over there. If you have two waves that are travelling towards each other, like this, and another wave that's coming towards it that's exactly the same, okay, same wavelength, same amplitude, then what you're going to see is a very interesting occurrence. You would see in the point where they're joining, it would go from points of nothing as the two waves move into a 180 degrees out of phase point, and then as it moves, continues to move, because the two waves are still moving even though a single photo snapshot would show them as flat like this. A moment later when they're both in phase, you would see that, boom, peaks, high peaks, with twice the amplitude from that central equilibrium position. So that's pretty cool, and that would be an example where you've got two people holding onto a skipping rope, and one person's flicking it that way, and the other person's flicking it that way to send a pulse down. Okay, very interesting situation. But that's all we really need to know about superposition, adding of waves.